Good morning.
Good morning.
So did y'all enjoy your good 3-day weekend?
Ours was 4 days.
Oh, that's right. Thanks for rubbing the salt in the wound there, Lauren. Um, so did anybody do anything amazing? No? All right. Well, let's see. So where's Jill?
She's putting some notes together.
Okay. All right. Oh, there she is. Okay. And let's see. Who are we missing in Holbrook?
Serena.
Serena. That's right. She emailed me. Anybody else? Okay. All right. Well, so I'm glad Jill's putting notes together because we are going to start 7.1 today. So tomorrow we are going to have our first major test of the semester. So chapter 6 test will be during our class time. Now, once again, you will get 2 attempts. You should be able to, based on what students have done in the past, you should be able to finish both attempts tomorrow. But if not, again, if you don't feel like you're going to have time, then don't start the second attempt, and we'll work out a time for you to take the second attempt, okay? But if you start it, then that's your attempt, okay? So what the main difference is going to be the number of problems. So but it'd be like last semester where the test had 20 questions on it. And so, but what I'm going to try to do is make it random again. A problem did come up, and I'm going to warn you about this. That's kind of stressing me out as far as the random thing is that I was told that it wouldn't repeat the problems, but apparently on the test this morning in calculus, it did repeat the problems. Have you guys had that come up in any of the quizzes where the same question is on more than once on a single quiz?
For all the second attempts that I've done, they've been exactly the same as the first attempts.
Okay.
For mine, there's usually like 1 or 2 different, but the rest are the same.
Yeah, I've had that.
That's mine too.
Okay, so, but no, what I'm asking is have you ever had it so that like question 1 and question 2 are exactly the same question?
No, I never have.
Okay, so that happened this morning in calculus, and that kind of stressed me out a little bit because that's not supposed to happen, and so I was a little frustrated with that. So okay, well that's good to know. So I don't know what happened there in calculus. I'll figure it out. So okay, all right. Any other questions, concerns? So just be ready, start right on time at 11 tomorrow. Have your calculator, your notes, your book right there ready to go. And I think you'll be just fine, okay? All right, well, let's go ahead and get started on on chapter 7. Okay, so this section is on fundamental identities and their uses. Whoops. Okay. So hopefully you took some time and copied down the formulas. And so we're going to, when we get to those pages, I'm not going to take up class time to have you copy those down. But my purpose here today is to get you familiar with the formulas, how we're going to use them, and so on. Okay, so in this first section, actually the whole focus of all of chapter 7 is trig identities and equations. So a lot of formulas in this chapter. Now it is kind of a short chapter, but there's a lot to it. So we're going to start with previously encountered identities, things that we've talked about, and then simplifying trig expressions, verifying trig identities. So that means like we're going to prove that they actually work, and then do some substitutions. Okay, so 4 ways in which the fundamental trig identities can be used. So we can use them to help evaluate. So when we're plugging in a number and we're trying to figure out what the final answer is, sometimes we can use identities to make our life easier or to simplify trig functions. It's like combining like terms, okay? And then developing additional identities. And then at the end of this chapter, we'll solve trigonometric equations, okay? And so that's going to be kind of a big idea. All right, so some of the identities that we've already seen. So first we have the reciprocal identities. So there you've got to remember what's the reciprocal of what. And so that's, again, the one that messes people up the most is that secant and cosecant. That cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Okay? And then we have the quotient identities, that the tangent is sine over cosine, cotangent is cosine over sine. Okay? So those are kind of the ones that we've talked about thus far. Okay, now let me just show you, for example, how we can derive another, how we can get, for example, that tangent is sine over cosine. All right, so we've learned that. That's one of our quotient identities. So if you remember SOHCAHTOA and you think of sine is the opposite over the hypotenuse, and then the cosine is adjacent over hypotenuse. See, the h's here, the hypotenuses, are going to cancel. And so what we're left with is opposite over adjacent, or tangent. And so that's kind of how we take one identity, or in this case, 2 identities, and come up with a third identity, that tangent is sine over cosine. So that's kind of the basic idea. All right, next we have the Pythagorean identities. All right, so the one that we want to know the most important one is this first one, that sine squared x plus cosine squared x equals 1. Okay, so I would even suggest you put a little star by that one, because you've got to memorize that. And then the other 2 we get from this. If we divide everything through by sine squared, then we get 1 plus cotangent squared equals cosecant squared. So we get the second one. And then if we take our original Pythagorean identity and divide by cosine squared, then we get the third Pythagorean identity, tangent squared x plus 1 equals secant squared x. Okay, so that's the Pythagorean identity. So we've worked with those. Okay, now the next one, let's see. Okay, let's do them like this. So the next we have the cofunction identities. So the way that this works is, so we talked about the complementary sign is actually, the abbreviation for that is cosine, is the same as complementary sign. So the sine of a number is the same, of an angle is the same as the cosine of its complement. So of 90 minus the angle. And so it works the other way. Cosine is the sine of 90 minus the angle. Tangent is the cotangent of 90 minus the angle, and so on. All right, so those we've had before. So just kind of applying that. So to do the sine of 3 degrees, that's the cosine of, well, you say 90 minus 3 is 87 degrees. And so the cofunction of the complementary angle. So cosine means the complementary sine. All right, then the even and odd identities, okay? So here, like, this is kind of tells you what to do if you have a negative in the argument as far as the angle goes, how to simplify that. So like if we have the sine of a negative x, you can pull the negative out front and make that negative sine x. So it works pretty much like that for all of them except cosine and secant, that because those are odd functions, those are odd angles, that if you have the cosine of a negative angle, then it's the same thing as the cosine of the positive angle. So it's like the negative just disappears on cosine and secant. Okay? Now, I never quite got that as a student, so why the negative would just disappear, and that's okay, until, I guess, and I don't know if this may or may not help you, but like if you imagine like 20-degree angle going up and you have an XY coordinate. Well, if you were to measure 20 degrees going down, the X would be the same. The X value, the Y value would be the opposite, but the X value would be the same. And so the X is the cosine. And so even though you change the angle from positive to negative, the X value is not going to change. The cosine is still the cosine. Okay? All right, then we have the period identities. And so the period identities, basically, if you just remember what the period of the functions are, that sine, cosine, cosecant, and secant, the period's all 2 pi. So if you add 2 pi or 360, it's just going around the circle. And so you're not changing anything. Now with tangent and cotangent, the period is just pi. So on those, you're just adding pi. On the other ones, when you add 2 pi, you get the original function. Okay? All right. So, part 2, simplifying trigonometric expressions. To simplify expressions, you look for ways to use the trig identities. All right, so here's an example. If I have cosine theta plus sine theta times tangent theta, and I'm just trying to simplify this. Okay? Well, I'm gonna teach you several different tricks for simplifying these because I'm gonna assume you've never done this before. Okay? So one trick is to rewrite everything in terms of sines and cosines. Okay? So you got to use those identities, the quotient identities, the reciprocal identities in particular. Okay, so cosine theta. So what you do is like tangent theta. You rewrite tangent as sine theta over cosine theta. Okay, so then if we try to simplify that, that gives us cosine theta plus sine squared over cosine theta. Now you might say, well, that doesn't look any simpler. That looks more confusing. That looks like more complicated. So next I'm going to teach you the second trick. And the second trick is to combine fractions. Okay? The first trick is rewriting as sines and cosines. The second trick is combining fractions. Okay? So here we have cosine. Well, cosine and 1 are my two denominators. So to rewrite this as a fraction, we would get a common denominator, which would be cosine. So if I multiply numerator and denominator by cosine, we'll just go, oops. Okay, then what I get is, so I'm multiplying numerator and denominator here by cosine. So then I get cosine squared over cosine plus sine squared over cosine. All right? So now I've got a common denominator, so I can put those over one denominator. So I get cosine squared plus sine squared over cosine. So now I've put those together. All right, now, can anyone tell me what's cosine squared theta plus sine squared theta equal to? It's equal to 1. So that's the first Pythagorean identity that I told you want to memorize because it's going to come up so much. So cosine squared plus sine squared, or sine squared plus cosine squared, however it's written, that's equal to 1. And so then what you're left with is 1 over cosine. All right, and now can anyone tell me what 1 over cosine is equal to?
Isn't it secant?
Secant theta. So that's your final answer. So we started off with something pretty complicated, and we ended up with just secant theta. Okay? Now, as you do these, don't get frustrated. Okay? Because like I say, this is all going to be new. So what you have to do is just try to do some things. Like rewrite everything as sines and cosines, combine fractions, look for an identity. And then if you get stuck, don't worry about it and just try to learn with practice. Like, oh, I needed to do this. Okay? So go ahead and try practice 2A. All right, so Naomi, tell me something that you did for this problem.
Well, I put everything in terms of sine and cosine so sine and cosine, and somehow ended up with 1 minus tangent of x, and I don't think that's right.
All right, well, let's see how far you... Okay, so secant is what in terms of sines and cosines?
1 over cosine.
Okay, and tangent is?
Sine over cosine.
Okay. And so you get this, right? Okay, now what?
And then I did multiplied the sine over cosine times sine x of x.
Okay, and what'd you get?
Sine x squared over cosine.
Okay. Okay. And since they have the same denominator, you can put those together.
Yeah.
Okay,
Yeah.
and is that as far as you got, or?
Well, yeah, and then I figured since sine over cosine is like tangent, that might have something to do with the answer, but then I...
No, because you've already dealt with tangent. You've already broke tangent down. Okay, so that's not it. Can anybody tell us where to go now? Jay? I didn't know, was that like... I'm not sure. Was that saying I know the answer?
They didn't
I'm
raise
just
their
playing.
hand.
I'm just playing defense here.
I was stretching, yeah.
Oh, okay. All
Alright.
right. Go
So
ahead.
if sine squared of x plus cosine squared of x is 1, then you can subtract the numerator and just get cosine squared of x, and then you can divide.
All right. So that's exactly it. So that is an excellent example of where we're still using that first Pythagorean identity that I told you to memorize, but kind of a derivation of it. So we're taking sine squared plus cosine squared equals 1, and then subtracting sine squared from it. So we get 1 minus sine squared. If you subtract sine squared from each side, then 1 minus sine squared is cosine squared. So that isn't the Pythagorean identity, but we're getting it from that. So if I replace 1 minus sine squared with cosine squared, all right, now what can I do?
Cancel out a cosine.
Yes, and so the final answer would be
Cosine of x.
cosine of x. Very good.
I'm sorry. You lost me. Sorry.
All right,
The
where
red part.
did you? What part did I lose you on?
The red. How did you get to that?
Okay, so the red sine squared plus cosine squared equals 1. That's the
Right.
Pythagorean identity. That's the first one. I told you to put a little star by it.
Mm-hmm.
Okay, and then if you subtract sine squared, it's just like in algebra 1. If I have a plus b equals 1, and then I could subtract a from both sides, I get b equals 1 minus a.
Okay, that makes
So, so I'm just moving that sine squared over to the other side.
Okay, so then how did you apply that to the green?
So then the 1 minus sine squared up here, I replace that with cosine squared. And then cosine. So then, just like x squared over x simplifies to just x, cosine squared over cosine simplifies to just cosine. Because one of the cosines will cancel.
That makes a lot more sense. Thank you.
Okay. All right. You're welcome. Any other questions? Okay. Whoops. Okay. On occasion, factoring or simplifying can best be done by first rewriting the expression in terms of sines and cosines. So now I'm actually having you write down what I told you earlier. We want to rewrite everything in terms of sines and cosines. That's almost the first thing I do in these type problems. Okay? So just watch this next example here. Okay? All right, so here I have cotangent alpha plus sine alpha over 1 plus cosine alpha. All right? Now, the problem here is the 1 plus. See, we can't just move this up or whatever. We've got a little difficulty there. But cotangent, I can rewrite that as what? Over what? In terms of sines and cosines, what is cotangent?
Cosine over sine.
Cosine over sine. Okay. All right, so then I can rewrite it like that. Okay, so now, what was the second trick I told you on these after you rewrite it in terms of sines and cosines?
Common denominator?
Get a common denominator. So here you have two different denominators. And so to get a common denominator, it's sine times 1 plus cosine. So what you do is you multiply numerator and denominator here by sine alpha, and then numerator and denominator here by 1 plus cosine alpha. Okay? So again, the whole purpose here is so that our common denominator, so sine alpha and 1 plus cosine alpha, sine alpha 1 plus cosine alpha is going to be our new denominator. Okay? All right, so now I don't even multiply it out. Just leave it as like sine alpha 1 plus cosine alpha. In the numerator, you have cosine alpha plus cosine squared alpha plus sine squared alpha. All right, now, can anyone tell me what is there anything up here that I can simplify?
Yes. You can do the cosine squared alpha plus sine squared alpha to be 1, right?
Yes. So again, that's 3 problems. We've done it 3 times. So that lets you know how important that trig identity is. Okay, so the cosine squared plus sine squared alpha, we can replace that with 1. Okay, now do you see anything that we could simplify?
Yeah, the denominator and the numerator you can get
Yeah,
rid of.
so 1 plus cosine alpha and cosine alpha plus 1, that's the same thing. So we can cancel those, and so we're left with 1 over sine alpha, and then what's 1 over sine equal to?
Cosecant.
Cosecant. So that's our final answer, is cosecant alpha. Okay? All right, so go ahead and try practice 2B. All right, so Raylan, did you get anywhere with this one?
I found the common denominators.
Okay. Well, actually, this one. Let's see. What am I doing here? Oh, this is a wrong problem. I'm looking at the wrong problem. There we go. Okay. All right. So, okay, let me make a note of that. All right. So, what's your common denominator?
Cosecant x times tangent x.
Okay. Okay. So, actually, so the common denominator, if you look at this has a denominator of tangent, this has a denominator of 1, then the common denominator is just tangent. So you don't have to multiply the second one by anything. You just, oh, you're telling me the final answer. Are you telling me the final answer?
No.
Oh, okay. All right. So do you see what I'm doing here is I'm multiplying tangent x, top and bottom by tangent x. Why? It's because I want a tangent x in the denominator to get that common denominator. All right, so Raylan, what's tangent x times tangent x? What's tangent times tangent?
Yes, you.
Say it again. What's tangent times tangent?
Tangent squared.
Tangent squared. Okay. So we have tangent squared x minus secant squared x. And so they both have the same denominator. So we can put them over tangent x. So put them all together in one fraction. Okay? All right, now, can anyone tell me how I can simplify tangent squared x minus secant squared x?
Secant squared x is tangent squared x plus 1.
Okay, so then if, so that's one of the Pythagorean identities. Okay, so how can I, so this is from the Pythagorean identities, how can I alter this so that it matches here in the numerator? What do I do?
Paper.
How do I get the red? How do I get the red to match what I have in the numerator here in blue?
Subtract tangent x.
Subtract tangent x. Well, that would give me a negative. That would give me secant squared minus tangent squared over here. I want it to be tangent squared minus secant squared.
You would subtract
What?
secant
Subtract 1.
and then subtract 1.
Yes. So whoops. So subtract the secant and subtract the 1. So then tangent squared minus secant squared, that's going to become negative 1. So negative 1 over tangent x. All right, and what will that simplify to? What's the reciprocal of tangent?
Cotangent.
It's a lot.
Cotangent. So then the final answer here would be negative cotangent x.
Okay, we did it a little bit differently, and
Did you get the same answer?
No.
So
What
what
did you
we
get
did-
for your final answer?
1.
1. Okay. All right. So tell me what you did.
So we took the first tangent of x and made it sine of x over cosine of x.
Okay.
And then we took the second
The
second
secant.
term, the secant squared over x. That's the same thing as tangent squared of x plus 1, right? So we changed that and then simplified the tangent squared x over the tangent squared of x over just the tangent of x to be
Okay.
just tangent of x plus 1. And then we simplified that tangent to also be sine of x over cosine of x. So we had sine of x over cosine of x minus sine of x over cosine of x plus 1.
Okay,
So we
wait. Can I say something?
Yeah.
So we did it, I think, in an easier way, in my opinion, but we did two things wrong. So we should have multiplied the negative through to the 1
Yes.
if we're going to do it that way. And the 1 was still over the tangent of x.
Correct.
So we would have gotten the right answer if we had just done that part. But I think we did it easier. But yeah.
Okay. All right. Well, let's just see what. Let's see if I've got it. Okay. So. All right. So let's see. So we have tangent squared x equals secant squared x minus 1. Okay. All right. So let me think here. So, okay. So tell me what you did first, Lauren or Jill.
So the first tangent of x, that first term, you're gonna
Yeah.
change that to sine of x over cosine of x.
Okay. All right. And then what?
And then we converted the secant squared of x to the
Tangent squared x plus 1.
Okay. Okay.
boom.
So then, what we did, and I'm not sure. What I'm not sure about is if. Okay. Well, so
Okay.
it's like
Let's
tangent-
let's go ahead and leave this as tangent x. Okay.
Wait.
All right. And then we'll distribute the negative and split this fraction. So
Yeah, so
tan
what we
x
did-
minus tan
We're
squared
trying
x.
We're trying to still do it in terms of sine and cosine, though.
Because you said
Right,
that's what we're
but I'm
supposed
saying
to do.
everything's going to cancel, so you don't need to switch them to sine and cosine.
Okay.
Okay? So
Yeah,
I'm trying to adapt yours and make it even easier. Maybe.
Okay.
Okay, so
Okay.
then what you do is you kind of, you split up the tangent squared x plus 1 into what you
And so tangent squared over tangent will simplify to
tangent of x.
tangent. So you have tangent x minus tangent x
And so those cancel. and then
minus
it's
1
just-
over tangent x. And so these cancel, and so then your final answer is negative cotangent x. All right? So great. So I do think that might be easier. And it illustrates, an important idea that, like the old saying, there's more than one way to microwave a cat. Okay? There's more than one, isn't that a saying? That's not a saying? Okay. Anyway, but there's more than one way to do these problems. So you might, again, and even that way you could break it down into sine over cosine. But see, when you actually said, well, then the sine over cosine is going to cancel with that sine over cosine, then I thought, then we don't need to even change it to sine over cosine because it's going to cancel anyway. Does that make sense? But you could. I mean, it's not going to mess you up if you did. Okay. All right. Any questions on that? All right. So next, verifying a trigonometric identity. Now, verifying a trigonometric identity is there's two ways to verifying an identity if you get stuck. Okay. Let's see. So, wait a second. No, that's not what goes on. I'm sorry. That's a different. Wait a second. Okay. All right. This is what goes with that. Sorry. Okay. So verifying a trigonometric identity. There's actually, there's 5 steps. Okay. Now with this, what we're actually trying to do, these are actually easier than the problems we've been doing. They're similar, but they're easier because you know what the answer is. On the last few problems, you're not quite sure. But here you do know, you're just trying to show that one side equals the second side. All right, so step 1, work with one side at a time. And that's the most complicated side is where you start. Okay? Step 2, you apply the trig identities as appropriate. Step 3, you rewrite in terms of sine and cosine if necessary. Get a common denominator and combine fractions. So again, it's a lot of the same algebraic steps. Okay, and then there's another algebra trick, factor and cancel where necessary, where appropriate. So that's another algebra trick. All right. So let's say, so here what we're going to try to do is with verifying, again, these problems are slightly easier because, see, it's like the same problem that we had, only now we know what the answer should be. Okay? And then if you get stuck on one side, you could actually work on the other side. Okay? But usually you start with the more complicated side. You say, okay, well, I'm going to do what I did before. I'm going to rewrite in terms of sines and cosines, and then I'm going to get a common denominator. So if you recall, I had one similar to this where I multiplied this top and bottom by 1 plus cosine and this fraction top and bottom by sine so that I would get a common denominator. Now, it looks messy, but it's really not that bad. You're just saying, okay, these denominators have nothing in common. So I've got to multiply this denominator by this and this denominator by that. Okay, and so that's what I'm doing in the next step. All right, so now I get this common denominator of sine times 1 plus cosine. Okay, in the numerator I get 1, so you distribute the cosine through 1 plus cosine squared, and then sine squared. All right, and then 1 plus cosine squared is 1, and then cosine x plus 1 cancels, so you get 1 over sine, which is cosecant. So now, see, once I got this to match what I started with, the cosecant, see, that tells me I know I'm done. I did it. I verified that it's true, that one side equals the other side. So it's very similar to what we've been doing. It's just you kind of have an endpoint. Okay? All right, so go ahead and try practice 3A.
Can you go back to the practice problem, please?
Sure.
Or the example?
Sure.
Okay, so I understand how you got the common denominator, but
Okay.
then if you scroll down a little bit, you get rid of cosine squared x and sine squared x on the numerator.
Right.
Can you walk me through that?
So that's from the very first Pythagorean identity, that sine squared plus cosine squared is 1. So now this matches this factor perfectly. So you can cancel this part that's in the parentheses with the entire numerator, leaving you with 1. And so then you have 1 over sine, which is cosecant.
Okay, thank you.
You bet. Okay, so Andres, if you get it before we run out of time, let us know. Or if you get stuck, let us know. Otherwise, we'll start off with this on Thursday. All right, let me give you a hint. What is cosecant?
1 over sine of x.
1 over sine of x. So sine times 1 over sine, what will that simplify to? 1. And so then you just have 1 minus sine squared. Well, by the Pythagorean identity, I guess I'm just telling you the answer, not giving you a hint. But because 1 minus sine squared is cosine squared, and you're done. Okay? So that deal of rewriting them in sines and cosines is big. Okay, so test tomorrow, chapter 6. Don't forget. Okay? Study, practice. If you don't study, you'll run out of time. You got to make sure you know immediately how to do things. And